This is Mr. Waters in another example for how to find the equation of an ellipse and graph the ellipse. And we're going to be given certain information. Now in this particular case we are going to be given that the center is at -3, 1. We're going to be given that the vertex is at -3, 3. And we're going to be given that one of the focal points is -3, 0. There's two, but that's one of the two. Okay, now keep in mind that the vertex, that means the point where the parabola intersects intersects the major axis. That gives us the location of the major axis. Now, in order to get an idea of what's going on, as usual, we will go ahead and graph this information. So I'll make a little, since we're going to have to graph it anyway. Okay, I'm going to make a sketch graph down here. Okay, so the center will be at -3, 1. That's going to be our center point. Okay, and then the vertex is at -3, 1, 2, 3. There's the vertex at -3, 3. And then at -3, 0 is one of the focus points. Okay? Now, to start with, we can see that the center of this is not at the origin. So we will use the general formula for a ellipse. We can also see that since the vertex and the center and the focal points are oriented vertically, this is going to be a vertically oriented ellipse. So that means it's going to be this formula in general: x minus h quantity squared over b squared plus y minus k quantity squared over a squared is equal to 1. Now, h and k are, of course, the center, which we're actually given. Since it's vertically oriented, a, the major axis distance, will be under the y, and the b, the minor axis distance, will be under the x. That's going to give us a vertically oriented ellipse. Okay, so well, now we just need to calculate a and b. Well, we can see from the information that we're given that the major axis distance from the center up to the vertex point is 2. So that tells us that a is equal to 2. We also are given here that the focal distance, the minor axis, or the focal distance, the distance from the center to one of the focal points, is 1. So that means that c is equal to 1. Okay, so we'll just go ahead. All we need to do is calculate b now, because we already have the a number for the formula. So we will plug in. We're going to say here that c squared is equal to a squared minus b squared, our basic ellipse formula. C squared will be 1 squared. That's going to be a squared, which is 2 squared, minus b squared. We scroll down here a little bit. Okay, that means that b squared is equal to 4 minus 1, which is equal to 3. So b is equal to rad 3, which for graphing purposes is about 1.7. Okay, so now we're going to use that information in our graphing here, okay, or in our equation. So we know that the b squared is equal to 3. We know that b squared in the equation is 3, so we're just going to put x minus, and the center point for that is -3 quantity squared. That's from the center point up there over 3, which is the b squared, plus y minus 1, again from the center point up there, quantity squared, and then that's going to be over 4, because a squared is given as 4, since a is equal to 2. A equal to 2, so a squared is equal to 4. And then that equals 1, so there's our equation. Now we don't have to do a whole lot extra up here to finish the graphing, but I'll go ahead and do this in a different color to help us see it better. Okay, now if this is the center here, or rather that's the center there at negative 3, 1, and it's 2 units up to the vertex up above, it has to be 2 units to the other vertex down below, so there's another vertex there. And then we count, and so this vertex point, the one up above, is negative 3, 3. This vertex point down below is negative 3, negative 1. So we have to write in the coordinates for the other vertex, the one below. Now the minor axis is about rad 3, or about 1.7. So we go about 1.7 to the left, which will be about there, and then from the center about 1.7 to the right. Okay, and that gives us the other minor axis point. Now we have to write the coordinates in. Okay, the center was negative 3, 1. The center x value is negative 3, 1. So this point is going to be negative 3 minus rad 3, comma 1. And then this point, since we're adding, is going to be negative 3 plus, or negative 3 plus rad 3, comma 1. And those would be the formal coordinates for those 2 points. Now lastly, we can go ahead and draw in the graph of our ellipse. And that should do it for us. So here is the equation right there, and there is the graph with each of the points labeled, the coordinates of the points labeled. Thank you.